Okay, these are just a few examples from R.7. We're going to do number 19 through 24 on my math lab. I just am looking at the equations as though I were a student. So yours might look a little different. It should be, the numbers might be different, or the numbers with the variables might be different, or the signs might be different, but it should be the same concept. So my first one is x over x plus 6 added to 3x minus 1 over x minus 6. So what I'm doing here when I'm adding two fractions, what I need them to have a common denominator, numerator, denominator. So the way to make this, even though the only difference is that this is addition and this is subtraction, there's no way to make those the same except to multiply this base by this base and multiply this base by this base. So if I take x minus 6 and I multiply it by x plus 6, that will be the denominator of my final answer. So if I multiply this one by this one, and then I do the same thing over here, right? Multiply this one by this one, they will both look like this. So that's what I want to do. To maintain equality of a fraction, if I multiply the bottom by a term, I want to multiply the top by the term because that makes sure that the fraction is still has the same value. So I'm going to take the x, multiply it by this base, and take this, multiply it by that base. Take the 3x minus 1, multiply it by this base, and then the x minus 6 and multiply it by that base. If I have to write it out again, that would be x times, so I'm doing this one, x times the quantity x minus 6 over the common denominator x minus 6 times x plus 6. You don't need to do anything to this. X minus 6, x plus 6. And then plus 3x minus 1 times x plus 6 over that same denominator. So now I have a common denominator. What I can do now is I can just add the top term and set it all equal, or sorry, set it all above x minus 6 times x plus 6. First, I want to factor it out. If you want to add it first, it doesn't really matter, but x times x is x squared. X times a negative 6 is minus 6x plus, you don't need to put parentheses around this whole thing because it's addition, but you can, okay? If it was subtraction, you would definitely need to because we're distributing that plus to each of the terms that we create as we factor this, okay? 3x times x is 3x squared. 3x times 6 is positive 18x. Negative 1 times x is just a minus x. Negative 1 times 6 is minus 6. All over x minus 6 times x plus 6. Good. Now, again, I said that you can put these in parentheses. That was just to remind you that if it was minus, you would need to put it in parentheses. So if you're just distributing the plus sign, it doesn't change any of the signs. So we can ignore that and we can combine like terms. So that's 1x squared, a positive 3x squared. We can combine those. And then we can also combine the negative 6x with the positive 18x with the negative x. Okay. So that leaves us with x squared plus 3x squared is a 4x squared. Negative 6 plus 18 minus 1. Negative 6 plus 18 minus 1 is 11. So that's 11x. Positive 11x minus 6 over x minus 6, x plus 6. And that would be our final answer for number 19. Okay, go on to number 20. 20 has x minus 3 over x plus 2. So it's looking similar, minus x plus 4 over x minus 2. So it's kind of the same format where the only difference is addition and subtraction. However, the difference is this was minus, this is subtraction, this was addition. Okay, so with subtraction, you just want to make sure to include the parentheses and then distribute that minus sign. But go ahead, if 19 made sense, go ahead and try this without me. So I want to make these into a common denominator. So I'm going to take the x minus 2, multiply it by x plus 2. Anything I do to the bottom, I do to the top. And then over here, I'm going to multiply everything by x minus 2. Good. Okay. So now if I rewrote this, it would be x minus 2 times x minus 3 over x minus 2 times x plus 2 minus x plus 4 times x plus 2 over x minus 2 times x plus 2. Good. Now again, you're just going to distribute. So x times x becomes x squared. X times a negative 3 is minus 3x. Negative 2 times x is negative 2x. Negative 2 times a negative 3 is a positive 6 over x minus 2, x plus 2, minus x times x is x squared. X times 2 is 2x. X times, sorry, 4 times x is plus 4x. 4 times 2 is 8. Good. Again, now we're just subtracting this one from this one, and we can put it all over the same denominator, x minus 2 times x plus 2. So I have x squared. Negative 3x minus 2x becomes negative 5x plus 6 minus, right? X squared. Positive 2x and positive 4x become plus 6x plus 8. So again, I'm distributing that negative, so that actually becomes x squared minus 5x plus 6 minus x squared minus 6x minus 8. Again, now we're just combining like terms. So we've got x squared minus x squared. We've got negative 5x, negative 6x. And then we've got positive 6, negative 8. So that becomes x squared minus x squared, eliminates the x squareds. Negative 5 minus 6 is a negative 11x. And then 6 minus 8 is minus 2 over x minus 2, x plus 2. So that was number 20. '21 is already different. So for 21, now the denominators are becoming more complex. So the numerator is just x, but the denominator is x squared minus 9x plus 8 minus x over x squared minus x minus 56. Okay, you can technically, right, multiply this by this and this by this to get a common denominator. But that is, it would take a long time if you didn't leave it in factored form. What my math lab wants you to do is they want you to factor each of these in order to find the common denominator. And as I do it, it might become clear why they want you to do that. So again, you leave the top the same. Instead of x squared minus 9x plus 8, you're just going to factor that into two binomials, beginning with x. If I want it to multiply to 8, but add to a negative 9, I'm probably going to choose negative 8 and negative 1, okay? And then this one becomes, sorry, bring down the minus, x over, and then we want to make another set of binomials. X squared minus x minus 56 becomes x 56. If I divide it by 8, I get 7. So there's one, I have an 8 and a 7 as my factors because 8 and 7 have a difference of 1, right? So it's a negative 56. It's going to multiply to a negative 56, but it's going to add to a negative 1. So if I say negative 8 and positive 7, negative 8 times positive 7, I get negative 56, right? And then negative 8 plus 7, I get negative 1. So that fits. So if you see now, you have a common factor between those two. So now instead of multiplying all of this by all of this, you can take, you want it to look the same, right? So to look the same, to bring back the example here, we just made sure that the final denominator had this term and had this term, right? So we multiplied this by this, we multiplied this by that, and they ended up with x minus 6, x plus 6. This one has x minus 8, x minus 7, and sorry, x minus 1 and x plus 7. But the x minus 8 is repeating. So what will our common denominator look like? Do we need two? We need x minus 8, right? And then we need x minus 1 because that's that denominator. Do I need to write x minus 8 again? No, it's already here. So it's x minus 8 times x minus 1 times x plus 7 is going to be our final common denominator because that includes this one. I see that one there, and I see that one there. Okay, so for that reason, we don't need to multiply this side by x minus 8, and we don't need to multiply this side by x minus 8. To get to this, all I need to multiply this by is the x plus 7. If I do that to the bottom, I'm going to do it to the top. Good. Here, the only thing I need to multiply it by is x minus 1. If I do it to the bottom, I need to do it to the top. Good. Okay. So we have x times x minus 7 over x plus 7. Sorry. Yikes. Plus 7. X minus 8. X minus 1 minus x times x minus 1 over x minus 8 times x plus 7 times x minus 1. Good. Okay, now I'm going to distribute these. It becomes x squared plus 7x, right? Minus x times x is x squared. X times a negative 1 is minus x. Okay. Good. All right, again, we have a minus sign, so we're going to need to distribute that. So I'm going to put them all together under one set of x plus 7 times x minus 8 times x minus 1. And that's all you need to do to the bottom. You can leave the bottom as is, unless, right, you see an x plus 7 up here, then you would start canceling. But I don't like that doesn't look like the case. So we have x squared plus 7x minus parentheses x squared minus x, because you need to distribute that minus sign, becomes x squared plus 7x minus x squared plus x. Good. X squared minus x squared, those cancel out if I'm combining like terms. So those two cancel, and all I have is 7x plus x. So I have 8x over x plus 7 times x minus 8 times x minus 1. So nothing, obviously nothing factors out. That's my final answer for number 21. Good. All right. 22. See if I can fit it on this piece of paper. 6x over x squared minus 1 minus 3 over x squared plus x minus 2. This is another one that we need to factor, okay? This is the difference of two perfect squares, right? Because the square root of x squared is x and the square root of 1 is 1, and there's a minus sign between them. So this factors to 6x over x plus 1 times x minus 1, because that's the difference of two squares rule, minus 3 over, I'm going to try to turn this into two binomials just like we did with number 21. So x squared plus x minus 2, it needs to multiply to a negative 2, and it needs to add to a positive 1. So I'm going to say plus 2 minus 1, right? Again, we don't need 4, we just need 3 because x minus 1 is common to both. So we have x minus 1 times x plus 1 times x plus 2. Right? That's going to be what our answer looks like. To get to that answer, I need to multiply this one by just x plus 2, right? I'm going to take that 6x and multiply it by x plus 2. Over here, to get to this final denominator, I need to multiply x plus 2 and x minus 1 by x plus 1. Good. I'm just going to distribute that out. 6x squared plus 12x over x plus 1 times x minus 1 times x plus 2. Minus, again, 3x plus 3, if I distribute the 3, over x plus 2 times x minus 1 times x plus 1. Good? Okay, now I can combine these two because I have a common denominator. It is 6x squared plus 12x. Let's distribute that negative right now. Minus 3x minus 3 over x plus 1 times x minus 1 times x plus 2. So that becomes 6x squared plus 12x minus 3x. So 12 minus 3 is 9, right? 9x minus 3. Now they do want it in factored form. So I don't think we can pull out any of these, but we can see if I look at 6, 9, and negative 3, I know that I can pull out a 3, right? So my factored form will be 3. 6x squared divided by 3 is 2x squared. 9x divided by 3 is plus 3. And then negative 3 divided by 3 is minus 1 over x plus 1 times x minus 1 times x plus 2. Good. Because of that 2x squared, I know that if I did this, right, I wouldn't have, okay, essentially what I want to say is this is not factorable. You can't simplify this. So we're not going to be able to eliminate any of these. So this is the final factored form. Okay, they're not going to ask you to take any further than when your answer looks like this. You've pulled out one term and you have a trinomial here. So that's the answer to 22. Let's do 23. So now we're getting into dividing fractions. Not easy. So 23 was 7, for me was 7 plus 1 over x divided by 1 minus 1 over x. Okay, I have a fraction inside a fraction. This is not exactly the way that my math lab explains it, but the way I look at it is I don't want a fraction in my fraction. I want to get rid of this fraction. Okay. So if I'm just looking, and you can write this horizontally too. You can write this as 7 plus 1 over x divided by 1 minus 1 over x. Okay. I still don't want this fraction. Okay. How do you get rid of a fraction? If I want to get rid of a denominator, I multiply the top and the bottom by that, right? If I multiply, or sorry, one second. Sorry, I take that one, the one is being divided by the x. So to cancel out I was still thinking about 22. To cancel out 1 being divided by x, I want to multiply that 1 by x and it cancels it. So pretend I didn't do that. 1 divided by x times x is 1, right? But to maintain the value, right? To maintain equality, anything I do here, I also have to do here, okay? So I want to get rid of 1 over x. I want to get rid of the x. What do I do? Okay, I'm going to rewrite it so it's going to be less confusing. 7 plus 1 over x divided by 1 minus 1 over x. Okay, I want to multiply this by x. If I multiply this term by x, I have to multiply every other term by x, right? If I want to maintain equality in the top and the bottom of the fraction, I need to multiply the bottom as well by x, both terms, okay? But that does work because now I can get rid of that and I can get rid of that one. So that becomes, now I'm just distributing those x's, or I'll just rewrite it. 7 times x plus 1 over x times x, right? Divided by 1 times x minus 1 over x times x. Good. Now I'm just going to distribute those. 7 times x is 7x plus, remember I said the reason I'm doing this is because if there's an x in the top and an x in the bottom, I can cancel them. So 1 divided by x times x is just 1. 1 times x is 1x minus, so think of this as 1 times x over x, right? Because I'm multiplying the whole thing by x, that means the x is on top. Anything you multiply by a whole number, you add that, you do it to the top, right? So that's 1 times x on the top over x on the bottom. Anytime you have a common denominator to the top, or sorry, a common factor to the numerator and the denominator, you can cancel it. So 1 divided by x times x just leaves us with 1. Okay, so in order to get rid of those fractions, what I did was I multiplied the entire expression by that denominator. And I got 7x plus 1 over x minus 1. Right? I wanted to get rid of that, so I multiplied this, 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 and this by that denominator. So our final answer for 23 is 7x plus 1 over 1x, or just x, minus 1. And, all right, 24. 24 is the problem 5 minus x plus 1 over x divided by 3 plus x minus 1 over x plus 1. So it's a lot like 23, where we had to get rid of the denominator by multiplying everything by that denominator. However, here the denominators were the same. Here they are not the same. So we have an x and we have an x plus 1. So it's just going to be a bit more complicated. I'm going to, again, change it from vertical to horizontal as my first step. So it's 5 minus x plus 1 over x divided by 3 plus x minus 1 over x plus 1. Okay, if we think about it, we need to get rid of this x and we need to get rid of this x plus 1. Okay, I just stopped the video and restarted 24 because I did it one step at a time. So I did it with x, and I multiplied the 5 by x, I multiplied this by x, I multiplied the 3 by x, and I multiplied this fraction by x. And then after I had all those answers, I went back through and I multiplied what I got by x plus 1 times x plus 1 times x plus 1 times x plus 1. And it caused me to make like at least 2 mistakes. And so I started over after I noticed 2 mistakes. Might have been more. What is easier? And I don't know what, I assumed it was more complicated, but just to like explain, but I think it's less complicated, is we need, right? We need both of these gone. So instead of going through and getting rid of this one and this one, I'm going to say that the common multiple of them is x times x plus 1, right? So if I multiply the 5 times x and x plus 1 in one step, I'm going to make fewer mistakes, okay? So I'm going to take both of these and multiply this term by it, multiply this term by it, multiply this term by it, and multiply this term by it, okay? X times x plus 1, okay? So let's start with 5. 5 times x times x plus 1 minus x plus 1 over x times x times x plus 1. Of course, I've run out of room. I'm going to pause. All right, I rewrote it. I write very crooked. All right, so I ran out of room, so I rewrote it. So I'm multiplying that term by x times x plus 1, that term by x times x plus 1, that term by x times x plus 1, and that term by x times x plus 1. The reason is that this x is going to eliminate this one. This x plus 1 is going to eliminate that one. Okay, and then everything else we have to multiply all the way through. So that's like saying here, that's saying 5 times x times x is x squared. X times 1 is x. So it's 5 times x squared plus 1 minus x, that's a plus, x plus 1 times, that's eliminated and that's eliminated, so x plus 1. Good. Divided by 3 times, same as this one, right? X times x is x squared, x times positive 1 is x. Goodness gracious. Another mistake. Small one though that I caught immediately. So that's x squared plus x, and then plus, again, that and that eliminated each other. So I have x minus 1, and I'm going to put parentheses around it, times x. Good? Okay, so rewritten, 5x squared plus 5x minus putting parentheses around it because I have to subtract all of that. X squared plus x plus x plus 1 divided by 3x squared plus 3x plus, not putting parentheses around it because it's an addition, so I don't have to distribute anything, x squared minus x. Good. So now that I don't have any fractions, I got rid of all my fractions, I can change it back to horizontal if I want. Or sorry, vertical if I want. This is to horizontal. Or you can combine like terms, whatever you prefer. I'm going to distribute that negative sign. So I have 5x squared plus 5x minus x squared minus x minus 1 divided by, what can I combine here? I can say this is 3x squared plus x squared, and this is 3x minus x. Good. So I get 3x squared plus x squared is 4x squared, and then 3x minus x is plus 2x. Good. Now I can combine like terms here. Here we have 5x squared minus x squared, and we have 5x minus x minus x. So that is 4x squared plus 5 minus 1 is 4 minus 1 is 3. X minus 1 divided by 4x squared plus 2x. So I'll write that vertically now. 4x squared plus 3x minus 1 over 4x squared plus 2x. So for this last one, for number 24, they do want you to simplify, or sorry, to factor if you can. So I see here, right, that I can factor out a 2x. Start with the bottom because it looks easier to me. So 4x squared divided by 2x leaves me with a 2x. And then 2x divided by 2x is just plus 1, right? Here, they're going to want me to do this. So just to check, right? So let's check. If I factor by grouping, right? 4x squared plus 3x minus 1, I need it to multiply to equal a negative 4 and add to equal a positive 3. Sorry about that. All right, so my factors are either 2 and 2 or 1 and 4, right? But it's a negative, so it could be negative 2 and positive 2 would not add to a 3. Negative 1 and positive 4 would add to a 3. Positive 1 and negative 4 would not add to a 3, right? So that becomes, you keep the first and last the same, so it's still 4x squared. It's still negative 1, and instead of that positive 3x, I have negative x plus 4x, right? And it doesn't matter what order I put them in, I'll get the same answer. Now I'm going to factor by grouping. So here's my first group, 4x squared minus x. All right, it's very dark. 4x squared minus x, I can pull out an x, and I get 4x minus 1, right? Here, I have a positive 4x minus 1. All I can pull out is a positive 1, so plus 1, and I get 4x minus 1. So my two factors are 4x minus 1 and x plus 1. Good. So that becomes 4x minus 1 and x plus 1. Nothing cancels, so that's my final answer for number 24. Thanks, guys.